Hey guys, welcome back to a wonderful new week. I hope you had a wonderful day off with the 3-day weekend because I know I'm going to.
Labor Day.
Yay!
You mean you already did?
Yeah, I totally already did.
We're recording this today on Thursday, but you're watching it on Tuesday. No.
So we're like
Wednesday?
almost a week ahead.
Anyway, let's move on, guys. Let's focus.
Okay, anyways, you've got all three of us here. Here again, you've got Coach Groves.
Newsome.
And Green.
Okay, Miss Green. So, today, our learning target. We're still working on adding and subtracting rational numbers. Our learning target today is we will add and subtract rational numbers by using the algorithm.
Now, this isn't new, guys. We started doing this last week, and we're putting it all together. And you did this last year, so let's just take a deep breath. We're gonna get through this.
Yes. So we have 5.5 minus -3/4. First off, I have a subtraction problem. Miss Newsom, what do I do every time I see a subtraction problem?
I'm pretty sure we went over this last week. I think you keep, change. Does everybody remember that?
I agree. One thing I have heard a lot in my classes, I don't know if you guys have heard this too. A lot of you guys are saying, but I learned it as KFC last year. Keep, flip, change. It's the exact same thing. We've just changed a word in it. You can do that.
Okay, now, before she goes on with this, I'm going to rewrite this problem again because you guys, it looks like an addition problem now, but that's not what it is originally. It is a subtraction problem originally. So what we're going to do is we're going to take that off, and when you do the keep, change, rewrite it because it makes it so much simpler.
Bring it on down.
Yes, please. So I'm going to rewrite this. And now, Ms. Groves, what you were doing is totally fine, but I'm going to just do that.
They might not have caught this right here.
And because I don't want you guys to get confused and be like, okay, was it addition? What is it? So here, this is the original problem, okay? And this is the changed one. So I'm going to
keep the first number.
keep this.
Change
the
the
sign.
Grab me a
operation.
highlighter.
I will.
Grab me some highlighters, okay? And then we're going to change that to that. I'm sorry I took over, Miss Groves.
Oh, you're fine.
Okay, we're grabbing some highlighters over there. Okay, anyway, continue.
So now that we've changed it, I love this. We rewrote the problem. We keep, changed it. 5.5 plus 3/4. There you go, keep. Then it was a change. Change the sign to addition. And then change the sign to the opposite. Same thing as adding the opposite. So we have 5.5 plus +3/4. Now, are they the same sign or different?
That's the first thing you need to ask yourself. Same signs or different? In this case, they're both going to be positive.
So they're the same sign. What do we do when we have a same sign problem?
Add them up.
Add them up.
And
So when I add a fraction, we know we have to find the common denominators. So first, our common denominator is going to be 4. When you are doing your common denominators, what you're doing is you're trying to find the numbers that go into it the same. This happens to be that 4 here. So I can change my 5.5 to something with a 4. So I've got this being multiplied by 2, that being multiplied by 2. So it's 2/4. So now I have 5 2/4 plus 3/4. Now I'm going to change this mixed number into an improper fraction. So
But you don't have to if you didn't want to. There's a couple ways that you could do this.
Okay, so keep going and then we'll do it again
Yes.
with a different way.
So the 5 times 4 is 20, plus 2 is the 22/4, plus 3/4. So then I've got 22 plus 3 is 25/4. So I have 25/4. And I can divide that out how many times?
4 goes into 25.
6
6 times.
So 6,
And I think there's one left over.
there's 1 left over. And that's my final answer.
All right, I just want to show you guys that there's another way that you can actually do this, like Miss Groves was saying. First thing, you look at the signs. Obviously, they're both positive. Second thing, you want to make sure that the denominators match up or else you're not going to be able to add this up. So you have 2 and 4. You want to find a number that both 2 and 4 go into. Well, guess what? 4 goes into 4 and 2 also goes into 4. So therefore, we can keep the 3/4. We keep our addition sign, and we just need to change this guy. And just like she said, 2 times 2 is 4, We keep our big 5, and if whatever we multiply this by, we have to do the top. So 1 times 2 is 2. See how these are equivalent? 2/4 is 1/2. Now, she went a step further and she changed this to improper and then added. You do not have to do that if you don't want to.
You can, and it
of
helps
course.
with subtracting, but in this case...
You could just bring this 5 down and add these up. 2 plus 3 is 5, and then you have 5/4. Now, most of you will notice 5/4 is improper. If you take 4 goes into 5 one time, so we'll take out 4 from this 5, which adds 1 more to the whole number, and you're left with 1/4 as well.
Which is our original answer
Yes, ma'am.
anyway.
So we just wanted you to see that there was 2 ways to solve this out.
Okay, we're going to go over one more, and then we are out. Here we go.
So we actually are going to go over this one because I like this one better. We have 1 2/5 plus -4. First off, I have seen this so many times this week. How do I make -4 a fraction? I put a 1 underneath it.
That's all you got to do, guys.
This fraction symbol, this division, that fraction line means division. -4 divided by 1
is -4.
Thank you. It is still -4. So you're dividing. Just think, what am I dividing by to keep the same thing? So now we have 1 2/5 plus -4/1.
What was the first thing that we told them to ask themselves?
Same sign or different?
Different.
They're different signs. Now, because they're different signs, I have to subtract my numbers. That does not mean it's a subtraction problem.
You keep it as a plus.
It is
Do not
still
change
an
it.
addition problem. I'm just subtracting
Remember the song.
numbers.
Different signs subtract.
So now let's turn this this mixed number into an improper fraction. We've got
Whoa, dude.
I don't know what I'm writing.
Blob. Moving on.
We've got 7/5
So, okay, 5 times 1 is 5, plus 2 is 7/5.
plus -4/1. I'm going to subtract these numbers, but I need my common denominators.
Yes.
So to make this, I'm going to multiply this by 5 and multiply this by 5.
Can I use 10 if I wanted to?
You could. It's the same thing.
Definitely.
It's just going to give you bigger numbers.
Okay.
And you'll have to simplify at the end.
Awesome.
Yes. So now I have 7/5 plus -20/5. So I'm going to subtract these numbers. I'm not necessarily going to write this down. I'm going to look at it and go, what's 20 minus 7? I am using that bigger number on top for this because it's not the order. It's all about subtracting the bigger from the larger.
The larger, yes. The smaller
I'm
from
sorry,
the larger. Yes.
The smaller from the larger. So 20 minus 7 is 13. And then I've got the fifths here. Now, is it going to be positive or negative? Was 20 bigger than 7?
I know.
What is it?
20 is bigger than 7, so we're going to take the negative sign.
So it's -13/5.
Good deal.
Okay,
So-
but I'm not done yet.
Oh, I'm sorry.
Oh,
It's improper.
It's
We're not
improper.
finished. We know for sure our answer is going to be negative, so make sure.
Oh, my goodness. Oh, my goodness gracious. Here we go. We're going to end this right now, guys, okay? -13/5, right?
So we've got 2 and 3/5. -2 and 3/5.
5 goes into 13 2 whole times, and you got 3 left over. And, guys,
It's a negative.
it's been a great day. Have a great evening. We're out. Oh, there it is.